Hello everyone, Wesley here. So I'm going to do another limiting reactant problem for you today. This problem is much more like a problem that you may encounter on a quiz or an exam, as it is much more into it than the last problem, and it has other little parts that you have to include into it. So let's get into it. So here's our balanced chemical equation, and here's the problem. Determine the limiting reactant when given a mass of B2O3 and a volume of NaOH. The NaOH solution is 11.5 molar concentration. Also, find the moles of excess reactant and the volume of water created. And here I put the molar masses here and the density of water, as you may need them. So, what we want to start with is determining the limiting reactant. So again, we need to take each of the reactants and convert them into a product. And we want to convert them both into the same product to see which one is the limiting reactant. So I'm going to start with B2O3, and I'm going to pick H2O as the product to go to, because eventually one of these is going to be determined to be the limiting reactant, and we'll be able to take that straight into making it into the volume of water created. So I'm going to start with B2O3, and the mass is there. And we want to convert it into moles. So we have our molar mass down here. Always remember to include your units here, especially what you're actually converting, like the B2O3. So when we look at the ratio here, we have, for every 1 mole of B2O3, we have 3 moles of water. So for every 1 mole of B2O3, we have 3 moles of H2O. And when you do this math in your calculator, you get 4.5 moles H2O. And now we need to do this again, but for our volume of NaOH. So we need to convert the NaOH volume to the H2O, moles of H2O. So start with our volume again. And when we look here, we see that we don't have like a density or anything to work with. We have our molar concentration. So what we need to remember is that our molar concentration is moles per liter. So when we do this, I'm going to take this and make it into liters. So for every 1,000 milliliters, we have 1 liter. When we take our molar concentration there, it's already in the right position. Moles NaOH. Liter NaOH. Then we have to look at the coefficients here. So for every 6 moles of NaOH, we have 3 moles of water. So for every 6 moles NaOH. We have 3 moles H2O. When you do this math, you get 4.7249 moles H2O. So now when you look at this, you see that this is the smaller value, so that makes the B2O3 the limiting reactant. And that makes the NaOH will be the excess reactant. So it is in excess. So now, since we've determined the limiting reactant and the excess reactant, the rest of the problem here is also find the moles of excess reactant and the volume of water created. So I'm gonna find the excess reactant, the moles of excess reactant first. So when we look at this, we see that this value is bigger than this one, and this is our actual yield here. This is actually theoretically what we will get of H2O. This value is impossible because we will run out of our limiting reactant. So we're going to take this theoretical value and subtract it from our actual value. And when we do this, we get 0.2249. This is moles of H2O. But this isn't our excess reactant. So now we need to take this value that we have here and convert that back into NaOH. So now we're going to take our moles water, H2. We're going to look at our coefficients again. And we see that we have, for every 3 moles of water, we have 6 moles NaOH. And when you do this math, you get 4.4449. So now this is moles NaOH. And this is how much excess reactant we'll have of our excess. That we will have left after the reaction. So we still have to determine the volume of water created. So to do that, we take this value here, because that is our limiting. This is from our limiting reactant. So we take our moles here, and we take the molar mass here, and we take our density to turn it into a volume, and the value you get for this is 81, 306. H2O. So that answers all the questions asked in our problem here. What is our limiting reactant, which is B2O3, and our excess reactant, how much excess reactant we'll have in moles, that's here, and the volume of water created, that is here. So those are all the things that were asked of us in the question here.